Hello and welcome to today's lesson on complex numbers. This is going to cover topics under the standard 1.3b in Algebra 2 and then also under that lesson in Study Island called complex numbers. Remember, as you're taking notes today, if I go too fast, you are more than welcome to pause and then rewind so you can stay caught back up. And as you're catching on to these problems, go ahead and pause at the beginning of one of the problems, work it out yourself, and then use the video to check yourself. And today we're going to start talking about an imaginary number, which everybody jokes, well, why are we using numbers that are imaginary? Why don't we just use the ones that are real? But it was just a way of creating a number I so that we can work with negative square roots. So I'm glad that you could join us today, and let's go ahead and take some notes.
Before we start looking at how to simplify complex numbers, we're going to want to look at what certain i's can break down to. So first of all, I is an imaginary number, and it's equal to the square root of -1. So like I said before, it's just this number, the way that mathematicians created in order to work with negative square roots or negative fourth roots and make them look more neat. So instead of writing a square root of -1, we're just writing the letter I in its place. And so when we're trying to simplify these, we need to know that I is the same as I. That makes sense. But I squared is going to simplify to -1. I cubed is going to simplify to -I. And I to the fourth is going to simplify to 1. And then this pattern repeats. So I to the fifth simplifies to I to the sixth simplifies to -1, I to the seventh simplifies to -I, and I to the eighth simplifies to 1, I to the ninth simplifies to I, and so on. It just keeps repeating for every 4. So this is something you're going to want to have memorized. If you want to see why it is that it breaks down this way, you can read about that in your Study Island lesson. I'm going to break these down like I would a normal square root, looking for perfect square numbers, the largest one possible. It's just that now, because it has the negative, I'm going to pull out a negative square root, -1 square root also. So that's just how this is going to look. So I'm going to have the square root of -1, and then I'm going to look at 32. What's the largest perfect square number that divides out of 32? Well, I have 16. And then I also have 16 times 2 is what gives me 32. So that's going to be how I'm going to break down -32 to simplify this square root. So -1, that's going to become I. And then the square root of 16, that becomes 4. And it's just, mathematicians just write the number in front of the I. And then square root of 2 doesn't break any further down, so I'm left with the square root of 2. And that's going to be my answer, D. Okay, this problem's going to be done similarly. I see that there's a negative underneath my square root, so the first thing I'm going to do is pull out a -1. And then I'm going to look at 180. 180, what's the largest perfect square number that divides into 180? And that's going to be this 36. So I'm going to pull out a square root of 36, and then 36 times 5 gives me 180. So I've broken down -180 into -1 times 36 times 5. And so now the square root of -1 is the same as I. So I'm going to write I instead of the negative square root of 1. And then the square root of 36 is 6, so I'm going to write that in front of the I. And then I can't break down the 5 anymore, so I just put that at the end of the problem. And that's going to make my answer A. The 6 just got cut off a little bit there. Now I have a problem that says, which of the following is equivalent to I to the 23rd power? This is when knowing that I is the same as I, and I squared is the same as -1, and I cubed is the same as negative I, and I fourth is the same as 1 is very easy. That makes this problem easier. Because the first thing you're going to do is, okay, how many times does I go into, or how many times does 4 go into 23? So 4 goes into 23 5 times with a remainder of 3. So what that means is I can rewrite I to the 23rd power like this. And so I to the 4th is 1. And 1 to the 5th power is still 1. So it's that remainder that we really care about, that I to the 3rd, the fact that it goes in 5 times with a remainder of 3, that remainder is going to tell us our problem. So I to the 3rd power, which was our remainder, is negative I. So that means that A is going to be our answer. So this next problem is going to be done the same way. I'm going to think, okay, how many times does 4 go into 30? Well, it goes in 7 times with a remainder of 2. So once again, it's that remainder that we care about. So my remainder is 2, so I'm going to think about, okay, what is I squared equivalent to? I squared is equivalent to negative 1, so that's my answer, D. Okay, so this problem here, I have to remember that when I have a power raised to 2 parts, that I just need to raise each part to the 4th power. So this is going to be 4 to the 4th power and I to the 4th power. 4 to the 4th power is 256, and you can use your calculator to check that if you need to. And then I remember from my notes that I to the 4th is the same as 1. 256 times 1 is 256, so that makes my answer C. Okay, we've looked at how to simplify imaginary numbers and complex numbers, and now we're going to look at how to add and subtract them. It's fairly easy. It's just combining like terms like we've done before with polynomials, and you basically just have to remember you're going to add or subtract the imaginary parts together, the parts with the I, and then the real parts together, so your regular number. So here you're going to add the 5 plus 4, because it's addition in between the parentheses, and that gives you 9. And then you have 3i minus 2i is just 1i, and that should be a lowercase I, but autocorrect must have changed it. So your answer here is just 9 plus I, and you're done. So here I have addition in between the parentheses, so I don't have to remember anything extra about my signs. So I'm just going to add between the parentheses. Negative 7 plus negative 7 is negative 14. And then negative 6i plus negative 2i is negative 8i. And you're done. That's because you can't combine an I number with a regular number with a constant, so your answer is B. Now, once again, as always, when you have subtraction, you're going to have to be more mindful of your signs. So one way you can do it is you can remember, okay, I'm going to do 9 minus a negative 7, which is 16. And you can always use your calculator to double check your signs. There's no shame in that. And then 6i minus I. And 6i minus I, there's an invisible 1 in front of there, is 5i. Okay. Another way of keeping track of all those signs is, and you want to do it this way, and I think this is an excellent way to get in the habit, and this is how I would do it if I was still learning this, is I would take the 9 plus the 6i, and all I'm doing is dropping the parentheses. But now I'm going to change it to plus, and in order to change this to a plus, this subtraction is going to change the sign of everything in the second parenthesis. So I'm going to have plus the 7 minus the 1i. And then I can add that. 9 plus 7 is 16. 6i minus 1i is positive 5i, or plus 5i. And I get the same answer, which is letter A. Okay, so here I have subtraction again, so I'm going to rewrite this as an addition problem so that I don't get confused. So the first part stays the same, but now there's a positive 3 in the parentheses, so it's going to be a minus 3. And then it's a minus 3i in the parentheses, so it's going to be a plus 3i when I drop the parentheses. And then I just combine like terms. I have negative 5 and a negative 3, or negative 5 minus 3 is negative 8. And then I have negative 6i and a plus 3i, and that's going to be a negative 3i, and that's my final answer, which is C. Now we are looking at multiplying square roots or radicals with negative numbers underneath the square root. All right, so you're going to follow your regular multiplication rules. So here we have parentheses, we're going to distribute, but before we do that, we have to remember to write these in form of I before we do the multiplication. So we can't just start multiplying now, because we won't be able to keep our signs straight and you'll end up with a mistake. So you have to remember that you have to convert these to I first. So to do that, the square root of negative 6 here, there's no perfect squares that divide into 6, and so I have that negative sign. So I'm just going to write it I square roots of 6 instead of having a negative 6. And then negative 16, well, the square root of positive 16 is 4, but it was negative, so I have to have an I in there to show that it was a negative 16. And then minus square roots of 2. Underneath that square root, the 2 is positive, so I don't have to do anything. And then I'm just going to distribute. So I'm going to take I square roots of 6 times 4i. And remember, when you're multiplying with radicals, you multiply the outside pieces and the inside pieces. So I'm going to multiply I times 4i, which is 4i squared. And then I have square root of 16, no square root, so it's just going to be a square root of 6, so it's just going to be the square root of 6 minus, and then I'm going to take the I square root of 6 times square root of 2. So I have an outside part of I, there's just an invisible 1 there, so I times the 1, or I times nothing, is I, and then the square root of 6 times the square root of 2 is going to be the square root of 12. And then I just look to see if there's anything I can simplify more. Here, I know that I squared is the same as negative 1, and 4 times negative 1 is negative 4. And then square root of 6, I can't simplify anymore. There's no perfect squares that divide into it. But 12, that breaks down into the square root of 4 and the square root of 3. The square root of 4 is 2. So I'm going to have minus 2i, and I can't break down that square root of 3 anymore, so square root of 3. And then, remembering all of my radical rules, the square root of 6 and square root of 3, those are different, so I can't add or subtract those two. So this is all the further I can take it, so that leaves my final answer as D. And now here I'm multiplying with 2 parts in both of these parentheses, so it's basically just a FOIL problem. So you're going to multiply your first term, so 3 times negative 2 is negative 6. You're going to multiply your outside term, so 3 times 4i is a plus 12i. And then you're going to multiply 2i times negative 2 is a minus 4i. And then 2 times 4i, or 2i times 4i is 8i squared. And then I just look to see if there's anything else I can simplify. There's nothing I can do with negative 6, but I can combine 12i minus 4i because they're like terms. They both have regular i's, and that's a plus 8i. And then here, I know that I squared is the same as negative 1. So 8 times negative 1 is a minus 8. And now I have two regular numbers that I can combine. So I'm not finished simplifying. Negative 6 minus 8 is negative 14 plus 8i. And now I'm finished simplifying. I can't go any further. And my final answer is C. All right, so now we're looking at the last operation with complex numbers, and that's dividing. We've added, subtracted, multiplied, and now we're dividing. And basically, when you're dividing complex numbers, you can't have a radical in the denominator in the bottom of your fraction, so you can't have a complex number, an imaginary piece, in the bottom, the denominator of the fraction. So in order to simplify that, to remove that, we're going to have to multiply the top and bottom by the conjugate of the denominator. And all the conjugate is you change the middle sign of that expression only. So if the denominator was 3 minus 4i, we would change that minus to a plus and multiply the top and bottom by 3 plus 4i. If it was negative 2 plus 4i, we would change that middle sign to a minus and multiply the negative 2 minus 4i by the top and the bottom. If it was negative 3 minus the square root of 5, we would change that subtraction in the middle only to a positive and multiply the top and the bottom by this. So in this problem, I'm dividing, and it has an I in the denominator, so I'm going to have to multiply the top and the bottom by the conjugate. The conjugate here is going to be 8 plus 9i. All I did was change that middle sign, and I multiplied the top and the bottom by 8 plus 9i by the conjugate. And so now it's just two FOIL problems. I'm going to take negative 3 times 8 is negative 24. And then negative 3 times 9i is negative 27i. And then I'm going to take the minus 4i times the 8 is negative 32i. And then negative 4i times 9i is negative 36i squared. And then I'm going to do the same with the bottom. I'm going to take the 8 times the 8, which is 64. I'm going to take 8 times 9i, which is 72i. I'm going to take negative 9i times 8, which is minus 72i. And then I'm going to take negative 9i times positive 9i, which is negative 81i squared. And so now I'm just going to see what I can simplify in the top and what I can simplify in the bottom. So in the top here, I have like terms. I have two terms that are i's that I'm going to combine. That's going to give me negative 24, and then negative 27i minus negative 32i is going to be negative 59i. And then this I squared here is the same as negative 1. So negative 36 times the negative 1 is going to be a plus 36. And then I'm going to do, and that's my numerator, and I'm just going to keep going with the numerator while I'm thinking about it. Now I have a negative 24 and a 36 that are both numbers that I can go ahead and combine, and that's going to leave me with 12. And then I have my minus 59i. And now the numerator is completely simplified. So I'm going to go ahead and look at my denominator. So my denominator has those I terms that I can combine. 72i minus 72i, though, leaves me with nothing. They cancel out. And that was the whole point in doing this, was to get rid of some I. So I've gotten rid of those i's. And I'm left with a 64. But here I know that I squared is the same as -1. From my notes in the beginning, and -81 times -1 is a plus 81. And then I can take 64 plus 81, which is 145. And now I'm going to look, okay, there's 3 pieces here. Is there any number I can divide out of 12, 59, and 145? There isn't, so that's going to be my final answer, which is D.
Thank you for joining us today, and I hope you learned something new.